the storm sit in your eyes, see the thorn twist in your side. I'll wait for you. Sleight of hand and twist of fate, a bed of me, she makes me wait. And I wait without you, without you. Through the storm, we reach the shore. You give it all, but I want more. And I'm waiting for you, without you. I can't live without you. Well, there's your video song for the day. That's from YouTube. They're without you. There you go. All right, a little different. So today we're going to take a look at chapter 4, and 4.1 is the first one, which brings us back to graphing. So chapter 4 is all about graphing still, but instead of graphing one line, like in chapter 3, it was just about one line, chapter 4 is going to be about 2 lines. And the thing that you're going to be looking for in chapter 4 is, do the lines touch? Do they intersect? And you might say, well, of course lines touch or intersect. No, not all of them. Because if they don't touch at all, then they're called parallel lines. Okay. So not all, 2 lines, they don't all always intersect. They might be parallel. So here's the thing. After you graph the 2 lines, and you either see that they touch or they don't. If they touch, you need to figure out, that's why you need to do a good job on your graphing. You need to figure out where they touch. In particular, what's the ordered pair, the X and the Y, that they are equations, systems of lines, linear equations. Turns out that the place that you find the X and the Y, they touch, works for both. When I say works, if you plug it in, the X and the Y, into both equations, it will be true. It has to be true. And that's the only point that will work for both. Now, if they don't touch, of course, they're parallel, then your answer to me and yourself would be no answers, like no solution. No solution would be the best answer possible. In the back of your book, that's what they say. So you have 3 possible scenarios. You graph it, they touch. Find where they touch. That's your answer. And to make sure that they work, then plug it back into the original. Second scenario, they're parallel, and it's obvious that they're parallel. Matter of fact, the only way that you know lines are parallel is when you get it in y equals mx plus b. If the slopes are the same, then you know they're going to be parallel. If the y-intercepts are different, you know they're going to be parallel. So parallel lines, the answer you write for me or make a statement yourself would be no solution. So number 1, if they touch, find the answer, the X and Y. Number 2, if they don't touch, they're parallel, no solution. And what about number 3? You say, well, it turns out that if you have 2 equations and you get it in y equals mx plus b, and they both look exactly the same, they are exactly the same, then the result is infinite solutions. And the reason why I say infinite is because you end up graphing exactly the same line, and they're touching a first problems that you might encounter. Just plug in 3 for x and 9 for y. Is it true for both of them? And if it is, then that's the answer. That's called the solution. So let's try this one. So we'll try 5x subtract 2y equals -3. And we're going to put in 3 for x and 9 for y, and see if it's true. So that's 15 subtract 18 and negative. So plug it in here. Let's see. This is 9, and then this is 3 times 3. Yes, yes. So 3 comma 9 is a solution. So you might say, well, what about 2 comma -5? What about that one? Well, try it. Try 2 comma -5. So we go back to the original here. 5x minus 2 times y is equal to -3. So put a 2 in for x. And then, so I'm trying this one right here. Put a 2 in for x and a -5 for y. You're wondering if that's true. So this is 10 plus 10. Of course, that's not equal to -3. So this is the only one, only answer. That's the only answer. Okay, try this one. This is your x, this is your y. Try this in both of these. So 2 times 4 minus 7, I wonder if that's equal to 8. 8 subtract 7 is not equal to 8. So don't even try this one. If it didn't work on one of them, it doesn't matter. It has to be true for both. So now try this one. So go back over here, plug it in to this one. So that'll be 2 times 3 minus, minus a -2. I wonder if that's equal to 8. 6 plus 2 is equal to 8. Yes. Now go to the other one, which would be, put it into x plus 3y equals 4. Put what in for x? Well, we go back to the one, this value we're trying here, x and y. Put 3 in for x plus 3 times, what is that, -2? I wonder if that equals 4. I wonder if 3 subtract 6 is equal to 4. No. So neither work. Neither work. It says determine whether either one of these is a solution. Neither are solutions. So now to the graphing part of it. What about the graphing? And in graphing this, what we're looking for, do these lines T-O-U-C-H, do they touch? Question mark, that's the question. So I'm going to take in blue, of course, blue pen, I'm going to take -3 x plus y is equal to negative 10, and then put it in slope intercept form. So I'm going to do blue. I'm going to go y is equal to 3x minus 10. And I'm going to start at negative 10. Well, where the heck's negative 10 for the y? It's way down here. Okay, this is negative 8, don't forget. And then down here you got negative 9, negative 10. So I'm going to start at negative 10. And then slope. Slope is 3 over 1. That's rise over run. Up 3, right 1 from here. Up 3, 1, 2, 3, run 1. Do it again. 1, 2, 3, run 1. And connect the dots. Now in red, we'll do the other one, which is x subtract y is equal to 6. So again, we're going to solve for y, because that's, to me, it's the easiest way of graphing these in slope-intercept form. I'm going to move the x to the right-hand side. So moving the x and subtract x from both sides. So I'm left with negative y is equal to negative x plus 6. And now I get rid of the negative sign by multiplying everything by negative 1. So everything's sign gets changed. I'm going to multiply everything by negative 1. That gives me y equals, and don't forget negative 1 has to go to the other side too. So negative 1 is equal to, negative, oh my gosh, sorry. Negative times a negative, a positive y, which I wrote. Negative times a negative is a positive x. And distribute the negative to the 6, subtract 6. So my m is equal to 1 and my b is equal to negative 6. Remind you about the slope in the y-intercept. Start at negative 6. And now the slope is 1 over 1. So up 1, right 1. Up 1, right 1. Well, isn't that counting? It looks like it's 2, comma 1, 2, 3, 4. 2, comma 4 is the ordered pair where they touch. Or if I'm looking for a solution, x equals 2 and y equals 4. X equals 2, y equals 4. Now, if you wonder if that really is true for both of these, you put in 2 and 4 to both of them and see if it's true. Put a 2 here and a 4. Put a 2. Okay, so negative 3 times 2 is negative 6. And 4. I just made a careless mistake, and you probably caught that, didn't you? You see down here? That's not 4. That's negative 4. Silly me. That's negative 4. So the answer is 2 comma negative 4. And now I'm going to go back and check it. So if I put in 2, that's negative 6, and add a negative 4, there's my negative 10. That's a good thing. So I made a careless mistake, but now I fixed it. And it's going to work for this one as well. Okay, here's the next one. I'm going to do blue to be x plus 3y equals negative 3. And then I'll do red to be y equals 1. So what I'm going to do is I'm going to solve for y again, because that's to me it's the easiest way of graphing. So I'm going to move the x over to the right-hand side. And then what I'm going to do is divide by 3. So that leaves me y equals, okay, now the numerical coefficient in front of the x is -1. So it's -1/3 is the slope times x. And then -3/3 is -1. So again, there is a 1 right here. There's a 1. So -1/3 is the slope. But start at -1 for the y-intercept. So that would be right here, -1. And since I put the negative with the numerator, that's down 1, and then right 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. And then connect the dots and see if, not if, it looks like a nice little line right there. Now the next line you want to do, which I haven't read, is very special. You notice it's only got one variable. And if you look back at your packet page, previous page, you'll notice that y equals, I think I had the variable a, but y all by itself is a horizontal line, a horizontal line. So y equals 1, for instance, y equals 1 is there, y equals 1 right there, and here, as well as, wow, good grief, right there. So I see it's going to touch. The question is where is it going to touch? I wonder if it touches right there. Looks like it, but I can check in a moment. I need to check it, actually. So I want to see if right there is the solution. It appears it's -4, -5, -6. It looks like x is equal to -6 and y is equal to 1. I wonder if that's true. Y equals -6. Excuse me, x equals -6. Here's check this. X equals -6. Y equals 1. Right here. So that's -6 plus 3 times 1. I wonder if that equals -3. Is -6 plus 3 equals -3, and that's a yes. And notice y is always 1 anyway. So this is my solution right here. That's my solution. So as you can see, it's really about graphing so far, and graphing and seeing where they touch and trying to find out exactly where they touch and then checking it on the side if you need to. Okay, blue. Solve for y. Divide by 3. One of these things that your y-intercept is a -2/3, you have to approximate where that is. And then maybe connect the dots. See, I didn't do a very good job on passing that through. That could be a problem on trying to guess the answer. That's not a very good job. And that red dot is from the other side of the paper. So let's try to ignore that. I'll just kind of eliminate that. That's not part of the answer. Okay, now this one here is a vertical line. So I'm going to have a vertical line at x equals 4, which is, let's see, 2, 3, 4. Right here is a vertical line. By the way, what's the slope of a vertical line? Undefined. Yeah, that's right. it looks like right here is the answer. I'll say, I wonder if 4 comma 6 question mark might be the answer. And so what I'll look at is I'll put a 4 here and a 6 there and see if I get -2. Okay, 4 times negative, that's -20. 6, 18. -20 plus 18. Looks like it's true. I think this is that's the answer. Okay, this one here, solve for y. So this one here, if I solve for y, which is the same as y equals -2x. And I want you to see something here. Look at the slopes. The numbers are exactly the same. They're going to be parallel. They'll be parallel. No solution because they're parallel. If you wanted to graph it, you'd start at 7 right here. That's 4, 5, 6, 7. You'd start at 7, and then you would go down to right 1. Down 1, 2, right 1. 1, 2, right 1. Now, where would you start with this one? What's the y-intercept on this one? I mean, -2 is the slope. What's the y-intercept? It's 0. It doesn't exist. It's 0. So start at 0, and then again, go down to 1, 2, right 1. And connect the dots. And they are parallel. So no solution is the statement. Now the last one I want to do is just show you, it's going to be F. I want to do letter F. It turns out that the equations are going to be exactly the same. So this one here, I'm just working the problem out and trying to not say anything, so just follow along. I'm going to have one line, they're the same. So this is the statement that you want right here at the end. Just make sure you say infinitely many solutions. Okay, so there you have it, 4.1. It's called Systems of Equations for the most part for the chapter. And we started off by looking at the graphing part of it. Okay, till another time, be safe.